the history of this field is very similar to the history of genetics. You start out with a black box, and you don't know at the beginning of this whole business anything about the concrete nature of the oscillator or where it is or anything.
For the first 10 years of the field, from 52 to another 10 years, the driving, burning question is, do clocks exist or not?
Jürgen Aschoff proposed to inspire young people in Japan in the field of chronobiology. At that time, we were so small. I could count less than 100. Nowadays, more than 500 scientists.
Our Japanese seem to be a very, very hard-working person, and we noticed the total amount of sleep decreased year by year, and so totally for last 40 years, almost 1 hour it decreased.
People in the government and the people in the big companies are getting aware of the importance of sleep.
I went down to and joined the University of Virginia because of this amazing Center for Biological Timing, which was truly this break point in the field. And of course it was fantastic because Takahashi and Rosbash and Jeff Hall and Mike Young would all fly down to UVA, and we would, alternatively, be fighting and then be kissing and making up. And it was a great time because we had to get together quite often. And Gene, somehow, like some amazing Pyrenean shepherd, would keep us all in order and box our ears when we got a little bit out of order.
We had Drosophila people who traditionally had not worked together. Mike Young, Jeff Hall, Michael Rosbash. That was being a referee among some tough folks. And so I was able to work my way through that, learn some valuable skills. And in the end, the sum was greater than the parts. I mean, they actually did great work together.
It was a very exciting time to be working on the problem. It was difficult sometimes working on the center, but it was the right thing to do, and I don't think anyone who did it has any regrets. It was absolutely the right thing to do for the field.
At one point, I wanted to do more experiments in constant darkness than I had room in this one tiny little room where I could turn out the lights and so on. So I thought, well, they do fine in the dark. I could probably just take out their eyes. So that's how that started. And I removed the eyes of these birds in order to be able to keep them in the dark. And then I realized, that's right, and then I realized that they were entrained to the light cycle in this room.
And I remember this distinctly, plotting the data in my office, sitting there. It's one of those eureka moments that you only get 2 or 3 times maybe in a career. Plotting the daily cycle of expression of frequency and looking at the results of light induction. That is, at any time of day when you turn on the lights, you get high level expression of freq, and realizing that was sufficient to explain the phase response curve.
We needed a way of doing genetics, and I just basically came up with this idea of making plants glow on and off. I'll be really honest with you, I can't remember a transforming event as to when I actually first got the idea, but we got it, and people thought we were a little nuts, quite frankly, at first.
We combined efforts between Stuart's electrophysiology expertise and Balaji's expertise in handling the flies, and mine in circadian biology. And what came of that was the discovery that olfaction in flies is under clock control.
My enthusiasm to have such a experimental facility was so large And so I asked a hospital, and there was almost empty houses. So I asked to borrow me, and I rebuilt the building, whole building, to do in order to isolation experiment, and that works.
The work on methamphetamine was very new, and I think it's important, becoming more important. But we were lucky to find that. We're still doing that kind of research. So it's nice to have some lifelong theme.
The radio tracking is very laborious, particularly when you're plowing through 4 feet deep snow that fills in your path as you go by, and winds howl up the mountain like express trains. And the temperature was bitterly cold then, and you just wear 8 thermal layers inside and outside all winter long, and count on stockpiling food for 4 months because you don't get down the treacherous mountain road till the snow melts out.
The people who are considered themselves chronobiologists come into this field from molecular expertise, endocrinological expertise, behavioral expertise, human work, and stay together as a unified field. So I think that's one of the great accomplishments.
We started off with some good ideas for what to do as a field. We did them, we reduced it to the molecular level, and that is now a firm basis on which to move to tissues and move to the whole organism.
The future will be in understanding the outputs and how they're controlled by the clock and how they help the animal adapt to the environment. I think those are really some big and powerful questions that we're just scratching the surface on at this point.
What's ahead is really the possibility of analyzing the adaptive significance of circadian organization. And of course, for ecology, I mean, we know almost nothing about the way in which circadian rhythms and circadian organization influence communities and interactions in the field and so on.
I think there's much to be discovered, and the field turns out to get more and more interesting because clock genes play other roles in control physiology and behavior, so it's growing, not shrinking.
I think really that the field has to take seriously that it's at the point now where it can have a bigger impact than science, cell, or nature.